I'm not sure why. It doesn't seem like everybody's in the quiz. I'm not sure why, but we should be taking the quiz if you haven't started yet. I only see 18 in there, and there's 20 people in the classroom right now. So let me know if you have.
What's the password for the
No,
quiz?
sorry, I accidentally bumped something and changed this. Class Act right there with a capital C and a capital A.
Okay, thank you.
Okay, most people have finished the quiz now, so I know a few people are going to be coming in on that. So today, no Po Joel, what we're trying to do, but basically what today we're doing is we're wrapping up Python, because on next Tuesday, we're going to start learning C++, a different language. And so what I'm going to do today is I'm going to kind of finish reviewing the POJL from last time, because we didn't really talk about everything, go over some of the concepts, go over some additional concepts and additional examples with Python classes, just to make sure that we're getting it. And then we're going to go over the Blackjack lab. And so that's what we have going on today. And I think you guys are seeing the syllabus, right? I just wanted to. Okay, so let's, last time we looked at these three models, and we didn't really get to talk much about model 3. And the thing about model 3, and by the way, let me just take a step back, because I wanted to put all of this code into a single replet. I made 3 different classes, Atom 1, Atom 2, and Atom 3, but that was to show 3 different versions. And the third version, the model 3, we had a class, right, that had all of the stuff from the previous examples, but it had this Avogadro's number, okay? And we can access that Avogadro's number, it turns out, inside of the class. And does anybody remember what was interesting about this particular variable? Possibly not. So I'm going to take a step back, and what I want to do is, this is all at the end of the slides, because we've seen the other slides. And I kind of started talking about this last time. Let me view. Okay, so Atom, and forget about the 1, 2, and 3, because we're just going to talk about we're just going to talk about a class called Atom. Atom is a class, and so I'm kind of showing this here. And when I make oxygen equals atom, I'm creating an instance of an atom. And when I make carbon equals atom, I create an instance of an atom. So we call these objects. Objects are instances of an atom, right? An atom is a concept, it's a prototype. And we can make things of that type. Just, by the way, like other variables in Python, right? An integer is a concept, and when we say a equals 10, we're making an instance of an integer. When we make a string, like if I say, S equals quote Kenyan, I'm creating an instance of a string called Kenyan that has Kenyan inside of it. Here, I'm making an instance of an atom, and I'm calling it oxygen. Here I'm making an instance of an atom, and I'm calling it carbon. These things are called objects. Instances of something are called objects. Now, inside of instances, what do we have? Well, one of the things that we have inside of instances are what we call instant variables, instance variables. And we always refer to an instances variables by the word self, to refer to the fact that we are talking about a value that's contained inside that object. So a carbon has a mass, and when we want to talk about carbon's mass inside of carbon, we use the word self.mass. when we want to talk about oxygen's mass, inside of the oxygen, we talk about self.mass. Now we can actually refer to oxygen's mass outside of oxygen. And of course, self doesn't work because we wouldn't know which self we were talking about. So when we're outside of an object, we can refer to the object's instance variables by putting the name of the object and then the name of the variable. We're doing the same thing here. Carbon dot mass is equal to 12.1. This oxygen dot mass, I have this arrow pointing up to here to say this refers to this. And of course this, whoops, sorry. Sorry, this refers to this. Then the other thing that I have that I define when I define a class is I define member functions. We call those methods. And so oxygen has a method called neutrons, and carbon does too. In fact, every object has all the methods of that class, right? And how do I call a method on a class? Well, I can actually show that because that would be nice to know, right? If I want to call oxygen's neutrons function, right? I can do this. If I want to call the neutrons function on carbon, I can do this. Whoops, if I spell things correctly. Right? So here, I don't know how to get this thing out of the way. Here, I'm creating an oxygen object. Here, I'm talking about oxygen's mass. Here, I'm calling oxygen's neutron method, neutron's function. And doing the same thing over here with carbon. So I can make as many atoms as I want. And there are all these self-contained things that I can do things with, right? So this sort of gives us the terminology of the sorts of things that are in a class. Now, it turns out today's stuff that we're going to be looking on classes work, I summarized those here. We're talking about classes. Python provides features that support object-oriented programming, including the ability to define new types of classes or classes, which we saw in the Pojalon classes. It's not easy to provide a crisp definition of object-oriented program, but we have already seen some of its characteristics. Programs are made up of object definitions and functions definitions, and most of the computation is expressed in terms of operations on objects. Each object definition corresponds to some object or concept in the real world, like an atom or like a bank account. And the functions that operate on that object correspond to ways real-world objects interact. So here's the terminology we've been looking at, right? We have a class, which is a user-defined prototype for an object. And then we have a class variable. Oh, let's skip that one for a second. We're going to get to that in a second. We have a data member, which is a class variable or an instance variable that holds data associated with the class and its objects. We're going to see that in a moment. So looking, I think I got somebody send me a text. Nope. Okay. Not sure what my beep was there. So anyway, we have instant variables, and an instant variable, remember, is a variable inside of an object. And then we have what we call instances of a class, and that is an object itself. So, and then instantiation is the concept of creating an object. That's when we call the constructor. That's when we call the underline, underline, init, underline, underline. That's called instantiation. And that's what I'm doing here. When I say oxygen equals atom, I'm saying create an instance of an atom, and that's called instantiation. And finally, the object itself is the thing that I've created when I've created an object, right? So when I say object is equal to atom, I create this object. Now, one of the things that we want to talk about, of course, again, when we looked at the code last time, we saw that there was a bunch of instance variables, right? And each atom has all of the variables, right? And also, each atom has methods. And it turns out that those methods can have variables inside them that are local variables, which are not instance variables, right? Those only last during the call to the function. And so we have to differentiate between variables that are associated with the instance, which stay around. They don't go away. They last a long time. They're long-lasting variables. Local variables, just as we've seen in other places, if we create a variable within any function, whether it's in a class or not, that's just a variable that gets created when the function is called, and when the function is over, doesn't exist anymore. Finally, the thing that we saw in Model 3 was this Avogadro's number. And the whole idea of an Avogadro's number is it's a class variable. It's not an instance variable. It's not a variable that's inside an object. It's inside the class itself. And so I always refer to class variables by putting the name of the class dot the name of the variable. And I can have as many of these things as I want. And I can refer to this variable inside of my objects, right? If I say atom.avogadro's inside of an object, I'm referring to this single variable that all the objects share. Also, outside of the object, I can refer to that variable, again, exactly the same way. Okay. Let's see an example of this in action. So we're going back here to this web page, which again, by the way, is this classes work today. Now let's look at a class that has a little bit of everything. Now let's say we want to make a model of an employee. An employee is a thing in the real world, and we want to build a way of representing an employee inside of our program. So what do? We define a class employee. This is a common base for all employees. And I want to have a class variable that keeps track of how many employees I have. So I'm going to make something called a class count. Then I have a, what do we call this? A constructor, right? And I can pass it a name and a salary. And this puts the name and the salary I pass to it inside the object. So each object has a name and a salary. And then look what it does here. Employee count is a class variable, and I say employee, because that's the name of the class, dot employee count plus equals to 1. What is this going to do?
It would increase the value of the class variable by 1.
Yeah, and when's it going to do that?
Whenever you're I guess running the class or instantiation.
That's right. Whenever you instantiate a new object, it's going to go ahead and count that. So here I have a function that displays a count, and here I have a function that displays the employee. Let's try this. Let's take this code and go to a REPL. And you should probably do the same thing. Okay. Okay, so let's take this code and put it in here. Okay. Now, let's see what I can do. I can make a new employee. I can make employee 1 is equal to what? Employee. And I have to pass it a name and a salary. So we'll have Bill Yakis. This is a funny character that me and my friends made up years ago. And let's say his salary is $50,000, right? And then I should be able to display the employee. So let's call display employee. Whoops. I'm going to create Bill, and then I'm going to display him. Then I'm also going to go ahead and display count, just for fun of it. And let's run this. I don't know why this is giving me an error here, but do I have a, oh, huh. Well, let's run it and see what the error it gives. Missing parentheses in call to print. Oh, there's a bug in here. There's missing parentheses here. So let's add that. For some reason, I know why now, actually, because I took this example from Python too. So I'm going to have to fix that in my web page. I'll do that later, but put parentheses in the print, and let's run this. And sure enough, it prints name, Bill Yakis, salary 50,000, employee, total employee 1. Now let's go ahead and copy this code. And for some reason, my computer is running slow. And let's make an employee 2. And this will be Lizzie Randolph, make up a name here. And she makes $75,000 a year. Now, we call this, and notice here we see our first employee, and we have total employee, probably I should say total employees 1, and here's total employees 2. Now notice I can also do this. I can say print employee, whoops, employee dot employee count. Oops. All right, so I can directly access this employee count by using employee, of course, or I can call the member function, but I'm always referring to the same employee, right? In fact, I can add a third employee, and I should then get That's Lester Snickley, and he makes 35,000. We run it. Sure enough, I get employees 3, right? So we see everything here. We see this class variable. So we see this instance variable. And we can make employees, and then we can do things to employees. Now, so I think I've shown pretty much everything here. So let's try to do this. Oh, next thing I want to show, it's not actually in here, but I want to show this. Oftentimes, and this is going to be important for the next project, oftentimes I put classes in files of their own. And so let's do this. Let's make an add a file, and let's make a file called employee.py, okay? And it's empty, of course. And what I'm going to do is I'm going to take the employee class and delete it out of here and put it in here, okay? Now, when I go to run this, it gives me an error because it doesn't know what employee is. Because what I have to do is I have to import employee from employee, because it turns out that, okay, am I doing this wrong? Okay, I think I'm doing this backwards. Sorry. I have to say from employee, and it just assumes that there's a PY. I'm saying from the employee file, import the employee class, and sure enough, it works. Okay? And this is kind of nice because if I have lots of functions, like say I have an employee for a class for an employee, I have a class for offices to keep track of offices. Maybe I have a class for, what else might I have? A class for inventory items, right? Whatever it is I need to represent, I can put as many of these files in here and have as many different classes as I want to define. Anybody have any questions at this point? Now, what I'd like you to try to do, and I'm going to give you a few minutes to do it, is to do this. Try to add a position attribute to the employee. In other words, whether they could be, a CEO or a programmer or a salesman or a janitor, right? So see if you can add a position and then add this position to the constructor and modify the code so that it includes the position, and then modify display employee so it prints this new attribute. So I'm going to give you a few minutes. And then make the position attribute have a default value of intern for that position. So let's try to do 1 through 4, and I'm going to give you like 5 minutes to work on this, okay? And I should have like music to play. Doom, 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 doom. So go ahead and try that. Remember, you got to put the parentheses. And I'm going to actually edit this to fix this code because it doesn't have parentheses in it. But Okay. Anybody get it done? Text me if you managed to say yes, if text me chat test yes if you got it working. Okay, well, let me give you a couple more minutes then. If you got it working, you're free to move on to some of the other things, but I'd like to give you guys a chance to try to get this working. By the way, so let's just talk about what we're going to have to do. Right, so we're going to have to modify the constructor to take a new attribute, a new parameter called position, and we're going to need to put that into ourself, right? And then we're going to have to modify display employee to print that when it prints the display. And then we have to modify, we'd like to modify our test code to test it out, right? Anybody else got it done? Couple people who've got it. Okay. So, hang on here. Okay, so let me share my thing. Okay, so let's talk about how we do this. So what we're going to want to do is modify the employee class first, and we're going to want to add a position attribute to the constructor. So what I can do is just do this. Now I wanted to, if I didn't give a position, I want to just default to intern. So let's just type this in here. So what this says is, if they pass the position, great. If they don't, position is going to be equal to intern. And then what I can do is say self dot position.
I think you're sharing the wrong screen.
Oh, what screen am I sharing?
I can see quiz 19 on a Chrome.
Okay.
No.
So let's see. I don't know what happened here. Great. Okay, so let's. Am I sharing it right one now?
Yes.
Okay. So what I want to do is add a position to my constructor so that I can pass it in, but I want it to be default to intern. So let's do that. And this says, hey, if they pass position, use it, otherwise set it to intern. And then I want to send my own variable to be equal to the position, right? Now the second thing I wanted to do was to, when I display the employee, I want to print the position out. So I'm going to say position in quotes just to give me some nice. And then I want to print self, right, dot position. Now this should do it, right? That adds a position to this employee class. Now, the program should still run. I haven't given anybody any positions, but the code should still run, and it does, and everybody has the position of intern because I said, hey, if they don't specify a position, make it an intern. Now let's make Bill Yakus a programmer, and let's make Lizzie a vice president, and let's let Lester Snickley not have anything. Let's see what happens. Sure enough, Bill Yakus is a programmer, Lizzie is a VP, and Lester is an intern, right? See how that worked? So it was pretty easy to update this class and add some new features. So going back to the classes, let's try something else. Let's write a method called raise percent, where percent is a percent raise to give to that person. Thus, raise 0.10 would give that employee a 10% raise, and test it out. So if we want to do this, oops, we want to go to an employee and we want to add a new function. We want to add a new member function. And so what I can do is I can say def raise. And of course, when I make a member function, it always has to start with self. And then I'm going to give percent. And then what am I going to want to do? Not sure why this is giving me this.
Take an input and convert it into an integer for the percentage.
Well, yeah, well, the percentage is a percentage, right? So it's going to be something like 0.1. So what I want to do is I want to say self.salary is celled. I'm not sure why this funky thing, let me do this because I don't like this. I want to make this all lined up there. That's better. I want to take the salary and I want to make it to be equal to the salary plus whatever that percentage is. So what I can do here's a little trick. I can say salary times 1 because I want the salary plus the percentage. Okay, so in other words, if they're getting a 10% raise, what I want to do is multiply salary by 1.1. If they're getting a 20% raise, I want to multiply the salary by 1.2. Does that make sense? And so,
Professor, doesn't the percent need to be divided by 100 for that? So if you say 10%,
well, we're
then it's
assuming
1.1.
that this is how we give somebody a raise. Employee 1 dot raise. Whoops. This says,
Oh, makes sense. Sorry.
right, I'm giving him a 10% raise, right? Not sure why I'm getting a, what did I do wrong here? Here's the raise, and I have, no, this is cute. Okay, so,
I got a weird error about the raise name. Like if I change the name of the function at work.
oh, you're right. That's so stupid of me. Raise is a special word. We can't use raise. So let's call it give raise. Okay. And then it'll work. Thank you. Raise is a function, is something that raises an exception. So now it will run. Well, we've got an indent problem here on line 5. I'm not sure what's going on here. Oh, I changed my indentation slightly and I had to make everything match up. Okay, there we go. So now, of course, we want to display employee. Oh, I see that I was not, I had this error all this time. Whoops. Okay, so employee 1 give raise, and then let's display employee 1 again, and let's see what happens. Sure enough, now Bill Yakis got this funky salary. I probably need to use a format to make it look better, but I'm not going to mess around with that, right? And I can go ahead and give employee 2 a 25% raise, and we'll see if that works. Sure enough, Lizzie Randolph now makes $93,750. Very nice, right? So we added a new method. So the whole cool thing is, and I want you to think about this, the beauty of all this is I can add things here without necessarily even having to modify my code here if it doesn't need to use it right now. I can play around with this and do things, right? The whole idea of this is that the employee encapsulates the employee's stuff without me having to think about it when I use it. Now let's go back over to here. Let's say we want to add an ID for each employee, right? Students have IDs, employees have IDs. Well, what we could do is we could have.
I think you're in
called,
my REPL, not your.
Okay, thank you. I was looking at it. Sorry. Thank you. So what I could do is I could make a next ID and start the next ID at 0. And every time I make somebody, I could make And well, actually, let's start out with 1 just for fun. Actually, we could start out with something even funner, like let's start out with 1,000, just so it looks a little bit more like an ID. And what I could do is I can say self.id is equal to next ID, and then I could do self.id plus equal 1. Oh, this is going to have to be employee, right? Because I'm using, whoops, right? So what I'm doing is I'm going to assign everybody an ID automatically. Now, of course, if I want to see the ID, I better add that to here. So let's say, quote, ID colon, comma, self dot ID. Okay, now let's run our code. And notice it didn't work. Oh, I said self.id. I wanted to increment employee.id. Sorry. So now let's run it and notice Bill Yakis is 1,000, Lindsay Randolph is 1,001, Lester Snickley is 1,002. Right? So I'm automatically creating an ID for each employee because I keep track of which ID that I'm always on. In fact, down here, I could, after all this is over, I could say print employee, clearly can't type today, employee dot next ID, just to see what my next ID is, and let's run it. Sure enough, my next ID is 1,003, right? So this allows me to keep track of my employees by ID. So again, what did I do? I created a new class variable called next ID to keep track of what's the next ID that's available for an employee. And then when I created an employee, I gave that employee whatever the next available ID is, and then I added 1. Now let's say I wanted my employees' IDs to be scattered a little bit. I could add 3 every time and run this. And notice this is 1,000, this is 1,003, and this is 1,006. Why would I want to do that? I don't know, but I could. But what this does is make sure that every employee has a unique ID. Now, I can also print employee1.salary. I don't necessarily have to go through the functions to get to the variables, right? I've got to put employee 1 here. If I want to put employee 1's salary, I can just do it, right? And so I can access an object's member variables simply by putting the name of the object and the variable. So this is code, very simple code that uses the object, and here the object is. So now, let's see if we can write a program that creates a list of employees, and it gives 3 options: add an employee, list employees, delete employee. Option 3 works by listing the employees, numbering them, and then asking you to enter the ID of the employee you want to delete. So let's think about this for a second. Let's see if we can do this without modifying employee at all. So I can get rid of all of this. And if I want to have a list of employees, I need to make a list, right? So I could make a list called employees and just make that be a blank list. Now, if I'm going to do this right, let's make a main program. Okay, and let's have it say option is equal to input and actually let me go back over to here because I don't like typing so much. I'm going to grab this. Enter one, add employee. Okay, so there we go. Right, and then I can say, while, actually, since this program doesn't have any end, I can actually do this. I'll just say while true. I enter this, and then if OP equals 1, I'm going to call a function called add employee. If option equals 2, I'm going to list employees. And if option, well, I should say else if. Delete employee, okay? This is generally the way you should write software. You break it down into functions, right? So I'm saying, I haven't written these functions yet, but else print what? Okay?
Professor, does the input need to be converted into an integer?
Yes. Okay. So we're going to ask, and then I can write 3 functions, right? Def add employee, def list employee, def delete. Actually, you know, I'm going to employee, you know, call this just okay. So see how simple that is. So now I can write these. I'll put returns in all these so that it works. And in fact, I'm kind of showing you how I would go about writing a program. So now everything should work, but it won't do anything. Let's just see what happens if we run it. Nothing, because we didn't call main. Let's see if it works. Okay, so clearly I should do this. But let's see if this works. 1, 2, 3, 5. What? Okay. So how do we add an employee? Well, what we want to do is we want to get the name, salary, and position. So I could do that. I could say name equals input name, right? Salary equals input salary, but I better turn that into an integer, right? And what? Position equals input position. So if I get those 3 things, I should be able to make a new employee, I'll call it E is equal to employee, right? Sub name, comma, salary, comma, position. Right, I'm not sure why this is giving me an error. Let me look at employee. Name, salary, position, yeah. And then, oh, yeah. And then I should be able to say employee dot append E, right? Oh, what did I do wrong here? Oh, I got rid of my thing from the top. From employee, import employee. Got to remember that, right? So what I could do is, just to see if it worked, E dot display employee. Now let's see what happens. We run this and we say add employee, name, bill, salary, $2,000, position, you know, scrubber. There it is. We'll add another employee. Sue, I need to put a colon after this. Position CEO. There we go. And she has an ID of 3, right? So we're making employees and we're adding them to a list. Now, let's see if we can list them. How are we going to list these employees? Well, we have a list called employees. So we should be able to do for E in employees, right? Because that's just a list. And what do I want to do? It's just E dot, I want to type this whole thing. I should be able to just display it. And that's it. Let's try this. Okay, so I'm going to say 1, add employees, bill, some salary, boy, big, massive salary, VP, 1, Sue, some salary, position, CEO, 2, didn't do anything. Huh. So, not sure. Oh, I think I know what's going on. Anybody know what's going on here?
You have to put brackets after display employee.
Right. So let's try it now. 1, bill, 10,000, program, 2, wait, there. So 1, Sue, VP, 2. There it is. So now we've made a thing that can list students. I mean, that's students, employees, right? So I can add another employee, salary, 30,000, clerk to, I can print, right? See how I now have a program that manages a list. And look at how simple this program is. It's all just here, right? And it manages a list of employees because the employee takes care of the employees. All I have to do is create the employees and add them to a list. I wonder what would happen if I were to look at that list. Let's put something in here. What happens if I just print employee? Okay, it'll let me do that. So let's add some employees. One, Bill, position, Prez, Sue. Whoops, I typed in the wrong thing. One, Bill, something. One, Sue, salary, VP. Two. Notice it prints a list, but the list is a list of object references. That's what happens if you print an object. You just get the object references, which is kind of messy looking. Now, how would we delete employees? Well, remember, does anybody remember how we remove something from a list?
We could use del.
Right. So here's what I'm going to suggest we do. Let's list employees first. And then say ID equals input, oops, int input, enter ID of employee. That allows us to pick an employee. So we're going to show them all the employees. And then what we can do is we can say if. How do we do that now? We have to find that employee, right? So I think we're going to have to go through the list of employees like this. For E and employees, F the ID is equal to E.ID, right? So I'm asking F, it's capital ID, right? I'm asking if the ID that they typed in matches the employee ID. I want to delete it. The problem is to delete something, we're deleting an object, right? So we use a DEL. And how does DEL work? Does anybody remember? Anybody?
It removes everything in one go. Like if like it would like get rid of the whole line, I guess, something like that.
Well, right. So, I mean, sort of. Just to recall, if I stop this program, if I have, A is equal to 1, 2, 3, 4, 5. Well, let's do this. Bill, comma, Sue, comma, Cindy. Okay, and print A. If I say remove, I'm sorry, DEL, A sub 1, and then I print A, notice the element number 1, which is Sue, is gone. So I need to know the index of the thing I want to delete. And so what I'm going to do is modify this code to say for I in range this is an alternative to get the indexes. In range employees, I actually want the length of the employees list. Then I can go through the list. And so what I'm going to have to do is say employees sub I. So I'm going to go through the list. And let's just test this out for now. Let's print let's print employees sub I dot display employee. In other words, let's display the employee that we found, and let's just see if that works. We're not actually going to delete it yet. We're going to test it. So let's do this. Let's add an employee. Bill, he makes $12, and his position is a, a dryer, whatever that is. Okay. Then we have one. We're going to add an employee, Sue, and she makes $34, and her position is a runner. Okay, let's list to see if everything's there. So let's do 3, delete employee. Oh, I forgot to take this out of there, so let's get rid of that. And so it says ID of employee. So if I print 1003, should put a colon in here. Whoops, not 2, 1003, it should print Sue. Let's see. Well, it did, but remember, what did it print? Employees.I display employee. It's odd because, let me do it again. Line 17. Oh, what in the world? Oh, I accidentally did something goofy here. So what this should do is this should go through all the employees and check to see if the employee I's for each employee, see if its ID matches the one we typed in. And then we want to try to display that employee. And of course it didn't work because I didn't put parentheses here. That was the whole problem. Wait. Not sure what's going on here. Stop. It could be just, there we go. 1, Bill, VP, 2, Sue. Oh, I typed in the wrong thing. Now I did that. Oh, great. All right, let's try this again. Okay. I don't have time to finish this because I wanted to talk about blackjack. So I got a good start on it though. And what I'll do is I'll finish it and I'll post the link inside this activity so you can go look at it, and you should probably look at it. Let's look at blackjack. Now, the way you play blackjack is the dealer takes 2 cards and the dealer gets 2 cards to you. And then the dealer shows you his first card, but not his second card. Right? And then you look at your cards, and if your cards are you add the score of your cards. If it's a number card, it's that many points. If it's a face card, it's always 10 points. With one exception, if it's an ace, it's special. An ace is either equal to a 1 or an 11, depending on what's best for you. So you can choose. And so the goal is to get as close to or equal to 21 without going over 21. You automatically lose if you go over 21. And so you look at your cards, and I don't know if this works. It's not found. Okay, I don't have that web version going. And so we're going to play this game. And so basically what happens is you decide, am I going to hold or am I going to ask for another card? And you keep asking for more cards until you're as close as you dare get to 21, and then you stand, and then you reveal your cards. The dealer reveals their cards, and whoever's closer to 21 without going over wins the hand. So we want to make a game for this, and then the program continues. I can't remember. I do have a play of the game. Dealing the cards, the dealer is showing, he only shows one card. You show both of your cards. That's your total, because a jack is worth 10 and a hearts is worth 10. I mean, a 10 is worth 10. And so you say, that's really good. So you say stand, and then it shows everything. And the dealer only had 3 cards for a total of 13, because he pulled one more card. You have 2 cards for a total of 20, and you win. So then you say you want to continue. The dealer has a hearts jack, and you have a 4 of hearts and a 3 of clubs for a total of 7. That's not very near 21, so you hit. You get an ace of spades, and it turns out that totals 15, and the dealer, if somebody hits 21, they automatically win, so you lose and the dealer wins. So you can kind of look through this. The key thing here is that I'm providing you with a starting point, and I'm giving you some classes. I give you 3 classes: a card class, a deck class, and a hand class. In a card class, each instance of a card represents 1 card. So what does a card have? A card has a suit, which is whether or not it's diamonds, aces, clubs, or spades, and a rank, which is 2 through 10, jack, king, queen, and ace. An ace actually is also a 1. So we have a card class. A deck class is a class that keeps track of a deck of cards. So a deck is going to contain a list of cards, just like we had a list of employees. A hand is similar to a deck, although a deck starts out with all the cards shuffled, and then you pull things out of the deck and you put them into a hand. So a hand is sort of like a deck, although you do different things with a hand, right? You create a hand, and a hand can either be a player or a dealer, and you can add a card to a hand. You can show the first card in your hand. You can show all the cards in your hand, which is actually the same as a show hand. It's just a fancier way to look at it. And then there's a tally that adds up the score of that hand, okay? So I am giving you this code. Where's it at here? I thought I had it already open. Apparently I don't. So let me open up the blackjack card. And so what you have to do is finish it. I've started it just like I have the last few things, right? Notice I have main, card, deck, and hand. And then I have a little bit of code. In fact, it does a lot already. It says dealing new cards. The dealer shows king of spades. The player shows, and then I haven't finished that function, a list of cards, and then hit or stand. So I can hit. You draw a 9 of spades. Game's not done. I've got a little bit of it in here. But if we look at a card, how does a card work? Well, a card's pretty simple. When we make a card, we give it a suit and a rank. And here are the suits. It's a list. I'm saying here's the ranks, and here's the suits, right? Clubs, diamonds, hearts, spades. Here's the ranks, ace through king. And then what I have is an array that tells you what the value of each of the rank is. So an ace is worth 11, or a 1, it turns out. 2 is worth 2, 3 is worth 3, 4 is worth 4, all the way up to jack is worth 10. So when I set up a card, what I do is I give it a suit, I give it a rank, and then I look up in the rank. I'll let you look at this, but I figure out what its rank is. I take the rank of the card, and if you remember what index does, this says look in the ranks and find the index of the rank we are, which is, if we happen to be a 5, it's going to be 0, 1, 2, 3, 4, and then look up that number here, and that's going to be the value of the card. So self.value, we literally look in the card and we look it up in this list and we get its value. I already wrote that for you, that works. Card info returns the rank, it says rank of suit. So that's why here it says king of spades, right? So a deck, what is a deck? A deck uses a card, so I say from card and point card. A deck, now, I'm not going to really talk about this, but what this does is it creates a deck of 52 cards. So cards is going to be a list of cards. This is using something called list comprehension that we haven't really talked about, but what this does is a shortcut for iterating through all the possible cards and ranks and making a list of all the cards. Here is shuffle. You have to write that. It creates the cards in order. And then here's a draw. All a draw does is pull out of the deck a card. I'm going to actually write one other function for you here now that I'm thinking about it. This is just for test function. Show deck. If I make a function called show deck, I can say for C in, remember I have self.cards. And then if we look at a card, what can we do with a card? We can get card info. So I'm going to say print C dot card info, comma, end equals space, just so that it's all on one line. Now, why did I do this? This is not a function you're going to use, but it's a great test function. After, in the game, what does the game do? The game first creates a new game, and in the new game, it creates a deck called the deck, and then it shuffles the deck. Let's go ahead and the deck dot show the deck, just for fun. And let's see what happens. Let's run this again. There it is. Ace of clubs, 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, 6 of clubs. So here's a list of all of the cards in the deck. Now, notice that they're not in sorted order. They're in sorted order, which is not what we want, right? So the point being that in the main code, in the deck, one of the options was we have a shuffle, and it's really easy to do this, but you're going to have to figure out a way to randomize the cards in the deck. So a deck contains a list of cards. A hand also contains a list of cards, but it also has an owner, and the owner defaults to a player, and the owner can either be a player or a dealer. You can add a card to a deck. You can show the first card in a deck. You can show the entire hand, and then there's a tally. Now, this is a simple tally that just adds up the values of the cards without considering the ace. You have to fix this. So bottom line is I've given you the beginning of a blackjack program. All you have to do is finish it. And it uses classes, okay? So I want you to spend some time thinking about that. Come to office hours if you're struggling with it. We're out of time now. Thanks for coming to class, and I will see you later.
Thank you, Professor.
Thank
See
you,
ya.
Professor. Bye.
Bye-bye.
Hey, Professor,
Yeah,
I have a quick question. On the syllabus for today, it says census name data is due, but I haven't been able to find a link for anything to.
oh, where's that at? Oh, is that in the, okay, that's something I forgot to take out. Let me get rid of that. Thank
Okay,
you.
so it should just be Python chapter 12, 1 through 5, and then the replets for today.
Is that in the Moodle or is that in the, is on the web page?
It's on the web page. I checked the Moodle, but I didn't see anything, so
Okay,
I
yeah,
couldn't find any.
yeah, that's something yeah, I'm deleting that as we speak, yes. There we go. All right, thanks.
Okay, great. Thank you. Bye.
Bye.
Yeah, hi. How are you doing?
I'm fine. How are you? It looks like Samaya has a question.
Yeah. Hey,
was
yeah,
gonna-
how are you doing?
Oh, never mind. I was gonna say just you can ignore my email, Professor. It's all good now.
Oh, okay.
Yeah,
Okay.
I've just gone over it.
I
I don't
haven't
really.
seen it yet, but yeah.
It was dramatic. It's fine.
Okay.
Thank you.
Yep, see ya.
All right, I'll leave there. Thank you.
Okay, see ya.